Guadans! How are you today? I hope everything is doing well in God's grace. Welcome to our first week. Our first lesson is all about generating patterns. This week, you will be able to learn how to generate patterns. Okay, let us have a recall. What is inductive reasoning? Inductive reasoning is the process of observing data, recognizing patterns, and making generalizations from these observations. A conjecture is a conclusion made from observing data or an educated guess based on patterns. In this lesson, you are going to apply and enhance your inductive reasoning skills. First, let us have some simple activity. Draw the next object in each picture or pattern. What do you think is the next object in each picture or pattern? We have here this triangle, square, and then pentagon. What do you think is the next pattern? Next, we have here this pattern. What do you think is the next pattern? And also this one. What do you think is the next pattern? What do you think is the next pattern for these pictures? Great going, Guadans! For the first one is, it's a hexagon because in here we have 3 sides, 4 sides, 5 sides, and then the next will be 6 sides. For this one is, the shaded part is in here, and then in here, in here. So, the next pattern would be, marvelous, Guadans, it is this one because the shaded region is moving in clockwise motion. How about this one? What do you think is the next pattern for this one? This will be your assignment, then be the next pattern for the last one. What do we mean by sequence? A sequence means an order in which one thing follows another in succession. Just like the previous exercise, it is a sequence. It is following another in succession. A sequence is an ordered list. Also, a sequence is a set of objects which is listed in a specific order, one after another. Each member or element in the sequence is called term. The terms in a sequence can be written as A1, A2, A3, A4, and so on up to AN, and so on. So for our first example, the triangle is the A1. The square is the A2, the pentagon is A3, and the hexagon is A4, and so on up to infinity. Sequences are classified as finite and infinite. What do we mean by finite and infinite? A finite sequence contains a limited number of terms. This means it has an end or it has a last term. For example, days of the week, we have from Sunday, Monday, Tuesday, up to Saturday. It ends up until Saturday. We only have 7 days of the week. Another example is the first 10 positive perfect squares. That is 1, 4, 9, 16, 25, 36, 49, 64, 81 until 100. Because the example just asks for the 10 positive perfect squares. So, the sequence will have only 10 terms. That's it. What about infinite? What do we mean by infinite? An infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping or it has no end term. The ellipsis or these 3 dots at the end of the sequences shows that the sequences are infinite. Sequence of counting numbers 1, 2, 3, 4, 5, and then up to the infinity. We have here the ellipsis. Another example is multiples of 5. That will be 5, 10, 15, 20, 25, and so on up to the infinity. Sometimes a pattern in the sequence can be obtained and the sequence can be written using a general term. General term or the nth term can be written as A sub n. Now let us find the several terms of a sequence given the general term. Example, find the first four terms of the sequence. An is equal to 2n minus 1. So our solution here is to find the first term. Of course, our n will be equal to 1, or it is a sub 1. A sub 1 is 2 times 1 minus 1. We just substituted the value of n. Since our n here is 1, then our a sub n becomes a sub 1, and then our 2 times n becomes 2 times 1, then minus 1. Then 2 times 1 is equal to 2. Minus 1 is 1. Then it means our first term, or a sub 1, is equal to 1. Next is a sub 2, or our second term. That will be a sub 2 is equal to 2 times 2 minus 1, which is equal to 3. Next is a sub 3. That is equal to 2 times 3 minus 1, which is equal to 5. What do you think is our a sub 4? Fantastic, Guadans! It is 7, because 2 times 4, it's 8, and then minus 1, it's 7. Next example, find the general term. Given several terms of the sequence. We have, the example is, write the general term of the sequence 15, 12, 19, 26, and 33. How are we going to do this? Our solution here is, we need to notice that each term is 7 more than the previous term. Then we have here the term, the first term, second term, third term, fourth term, fifth term, and the nth term, or the general term. And then our given was, for the first term, 5, second 12, 19, 26, 33, and so on. So the pattern is, from the first one, 5, and then 5 plus 7. For 19, 5 plus 7 plus 7. For the 26, the pattern is 5 plus 7 plus 7 plus 7. 33 is 5 plus 7 plus 7 plus 7 plus 7. So to find the general term, we will by just observing, 5 plus 7 times 0 is also equal to 5. And then 5 plus 7, 7 is equal to 12. Then 5 plus 7 times 2 is equal to 19, and so on. Then we notice that the number 4 is the n minus 1. For example, this 3. Our n here is 4, and then minus 1, it's 3. That's why we have here 5 plus 7 times 3. Then our general term is, then we simplify, we distribute. 5 plus 7 times n is 7n, and then 7 times negative 1 is negative 1. So this will be 5 plus 7n minus 7. Next, combine the similar terms. 5 and negative 7 are both constant. So negative 7 plus 5 is negative 2. So our general term is a sub n is equal to 7n minus 2. It means for us to be able to find the, for example, the 100th term, then we will use a sub 100 is equal to 7 times 100 minus 2. Next example, write the general term for the sequence 2, 4, 8, 16, 32, and so on. Our solution here is, we notice that each term is 2 times the previous term. Then we have the term, first term is 2, second term is 4, third term is 8, and the fifth term is 32. And then we notice that each term is twice the previous term. So 4 is 2 twice of the previous term. 8 is also twice of the previous term. And then the pattern is 2 raised to 1. Next one is 2 raised to 2. And then we notice that our general term, or a sub n, is equal to 2 raised to n. All we have to do is to substitute the value of n to the exponent. Guadans, always remember that just like these numbers, our life is also full of sequences. May our life have a sequence of doing good and doing good by serving God and others. That's it, Guadans. Thank you so much for learning with me and always enjoy mathematics. God bless.